Okay, hello. We're here to give a presentation on X3D graphics. My name is Don Brutzman,
And I'm Dick Puck, and we're happy to have
and
you
we're
with us.
yeah, very much so. Let's get some sharing going here. Okay, we should have a screen coming across. Is that the case?
Yes.
Great. So, as you can all see on the title, we're going to talk about X3D graphics. It is an international standard. We are working on, of all things, version 4 after all these many years. So we're going to give you an update and where's the spec at. And we're also going to point out a whole bunch of resources and capabilities that are out there. Dick Puck and I have been working with X3D for many years and happy to be working together with them as specification editor with the X3D working group and with ISO. Okay, so let's keep going here. So we have a summary of all the things in this talk, and it's quite dense. There's a lot of information here. That's because X3D is pretty big. It's a big vocabulary, but it's also coherent, and we've mapped it in many, many different directions. File formats, we've preserved ClassicVRML, we've got XML, we've got JSON, we've got programming languages. We're gonna walk through all of that. We're gonna walk through tools, and we're gonna especially highlight some of the new features in X3D4 that add to the richness we already have.
It's important to note that throughout all of this enhancement, we have been very careful to avoid breaking backwards compatibility. So your old program should still work fine.
All right, so here's a short list of topics that we're going to cover, and it's really two parts. First is all the spec geeky stuff, and then second half is an inventory of resources, lots of cool stuff, so you can pretty much jump in wherever you want and work on things, utilize X3D4 as best makes sense for you. Okay, so here's our first part. The Web3D Consortium. What is Web3D? Well, when we first did VRML way back in 1997, we said, gee, we want to protect this international standard so that nobody can break it, nobody can take it, nobody can make it go away. So we incorporated a nonprofit that is been recognized as a standards development organization, formerly by ISO, and we have a very special relationship. We're in charge of all the spec development and making it all work, and then they're in charge of all of the formalization of documents and the rigor that make it useful for everybody. So it's quite a balance, quite an effective balance. Dick, can you tell us a little more about ISO and how that business goes?
Yeah, the standards development of X3D and the other Web3D standards is through ISO, a joint technical committee of ISO and IEC. ISO is the International Standards Organization, and IEC is International Electrotechnical Committee, which is mostly hardware standards. We have been working on this since 1997, although computer graphics standards have been developed since about 1980. But for the point of view of the Web3D Consortium, the primary standards, sets of standards are VRML, HANIM, and X3D. And each of those are multi-part standards. So each part having a designated role in the standards adoption process.
And the original Vermal is Vermal 1. Vermal 97 had 2 iterations, Vermal 2.0, and then there was a revision to it. And then when we went to X3D, it became 3.0, which then led to 3.1 and 3.2, 3.3, and now we're on 4.0. So you can see that we've had a lot of versions over the years. So it hasn't just been sitting around waiting. The X in X3D is extensible, so we continue to build stuff out, and we've managed to achieve backwards compatibility all the way by being cautious, by thinking about forwards compatibility into the future. How do we do new things without breaking old things? So here we are today. That's what this slide set is telling you about, that X3D4 is a major upgrade to X3D. It has not broken it, and the primary things are HTML5. How do we integrate well with web pages? How do we utilize physically based rendering and other advanced lighting techniques from Chronos in the glTF, and also advanced audio and a few other things. So we're nothing if not diligent and purposeful. You can look up our strategy and our working groups to see that the organization of a Web3D consortium really gives us structure that we can make sure all voices are heard, all priorities are balanced, everything keeps going slowly, surely. What do you think, Dick? Is it working?
I think it's working. People might be interested in knowing the reason why we changed the name from Vermal to X3D. That was because in order to enhance future growth, we came up with splitting the representation of the scene from the definition of the elements of the scene. So we call the definition of the elements the abstract specification, and that's what X3D Part 1 is all about. And then we have the ability to go to the ISO/IEC 19776, which is all the encodings. So far, we've got 3 standard encodings, and we're planning on standardizing at least 3 more. But each of these exactly represents the scene in the same way, so you can map between them. Similarly, we have a scene access interface that allows you to, from a separate program, interact with the scene, add things, remove things, change things. And that's called the scene access interface. And we have language bindings to the scene access interface so that from whatever language you're programming in, you can call programs in that language to make changes to the scene.
Cheers. And it's definitely a team sport, lots of working groups, lots of feedback from the public, and a real insistence on implement and evaluate before anything gets stabilized. So here's some key references for all this stuff. We don't expect anybody to memorize everything on the, boy, it takes a while. But we do want to let you know, oh, there's a lot of good things here. And you might find most interesting is our tutorial last year. And in fact, there's a lot of tutorials. 2020 was our 25th anniversary. We're now on our second 25 years. It's been quite a journey, and the Web3D conference is not solely X3D and Vermal. It's a lot of other good things too, but it's been a real foundation for what we're up to. So you can go check out all this stuff last year, this year, hopefully next year too. Dick, you were just talking about the different branches of the specification here they are again.
Yeah, note that by splitting them apart this way, it means that each of the different standards has the ability to progress or change on its own. And typically the part 1 of 19775, which is the X3 architecture, the abstract specification and definition of the scene graph, and then the X3D scene access interface allows you to interact with the scene graph. 19776 are the file encodings. I mentioned those a little earlier. And 19777 are the language bindings for various programming languages. We started off with JavaScript and Java, and are in the process of adding 3 versions of the C, C++, and C# programming languages, as well as Python. The 19774 is a completely independent standard called Humanoid Animation, which allows you to represent in a standardized way articulated figures, which may or may not be humans. They could be any kind of weird alien character that you want, but it's designed to handle any level of articulation. The X3D architecture has a component in it that references the humanoid animation standard. So you have all of the capabilities of the HANIM standard accessible from the X3D standard.
And that last point is perhaps the most important. The architecture describes all the functionality. That's where we say, here's how it works. And all these other things are variations on that consistent theme. How do we make it look the same everywhere? So that's a big statement. Boy, here's kind of our City of London subway map. How do all these things fit together? And you can see right here in the middle, there's that architecture. That's the document we're primarily talking about today. How does it work? And then we have, what are the different ways to say it? Is as a file, we have X3D XML or ClassicVRML, which looks just like the regular VRML, except the version number at the top, and all these other encodings, JSON, compressed, etc. Then we have programming languages. How do we say the exact same scene graph in this language, in that language, and the other? So X3D Anywhere is definitely part of it. And then as you go outside the center of the diagram, we show the corresponding references. What are the other standards that we're aligning with so that our X3D core, our common architecture, is the same and rigorous and correct for all these other ways of doing business? There's about 83 other things on this particular graphic, Dick. Is there anything else you want to point out or mention?
We should point out that the things that are surrounded by dashed lines are things in process, while the things with solid lines are things that have been published.
And if you ever want to go to a detailed meeting, boy, you should see when we figure out what's a solid, dashed, different lines. There's our legend there. There's our key. And it's been gratifying to see. Well, we don't get a lot of strokes, but turning a dotted line into a solid line is a good day because it means we got a lot of work done. Okay, so this is kind of your reference card for how do these all fit together. The fact remains, it's the architecture that's the center of gravity for everything. Okay, so what's new? What's new? Well, this is the biggest. I think almost anybody in graphics would vote for this as the most important thing. We've maintained a fairly old rendering model but we've now aligned with glTF, which is Chronos' very advanced GL transmission format for 3D models. And so we are matching all the render capabilities and all of the lighting capabilities and other goodnesses so that X3D models can load glTF, or they can convert from glTF, or they can maintain older versions and new polygons, old polygons can coexist side by side. We haven't thrown anything out. Dick, what's your favorite part about this relationship? It's a pretty deep one here.
Well, we've been working with Chronos for some time, and we're finding that glTF is a good way of describing models accurately so that they look like they should look. If they're metal, they should look like metal. If they're plastic, they should look like plastic. And so the physically based rendering part of the X3D specification supports all of the things required by glTF. And there really isn't anything in glTF currently in the version 2.0 version of glTF that we can't represent in X3D.
Yeah, and that's so important because that means there's no choice. There's no competition. There's no false decision point. You want it glTF? Great. You want X3D? Great. You want both? Great. It's use the right tool for the right purpose. Use the right file format in the right context. And our goal is get all the 3D on the web. This is a big step. And we don't have to worry about misstepping here because of this very solid relationship. Anita Havale is our executive director. She's been instrumental, along with a few others, to get this ongoing relationship solid so that the tech can align and the business models of different organizations can be fully respected without any short circuiting. Okay, next big thing. We're able to auto-generate large parts of that subway map you saw. We're able to auto-generate program language bindings. And we did this by creating a machine-readable version of what the architecture document says. The architecture document is all HTML. It's an ISO standard. So we captured that in a way that can be used to produce code that exactly matches it. So we get validation, we get consistency, we get second implementations in multiple directions that can help us stay all this on. There are some links here. There's some more description later in the talk, but we're adding all these things. We're excited that C, C++, C# are on the brink of active improvement now. We have an initial implementation and documents from our partners in Korea, and we're keen to keep building out on that. Okay, next is we've mentioned Chronos and glTF. We should also mention, let's see, I think I have to turn off my laser beam here. If it lets me. Okay, now I can actually click on a link. HTML authoring guidelines. We did not come up with something strict, but rather guidelines for how X3D can coexist inside the formal standards for HTML and for CSS. And in many cases, it sort of looks like SVG, how that fits too. So there's many considerations. This diagram is perhaps most illustrative. If we have HTML and it's drawing pages, and we have X3D and it's drawing 3D seeds. Well, you can put it in, you can intersperse the HTML and the X3D, and everybody plays well with each other. 3D is a much faster cycle update rate, user interaction rate, but HTML has one too. So we've described how that works. We have not legislated one way to do it, but rather say, here are the outcomes, here are the results, here are the behaviors and the displays that a user can expect. This keeps the door open for implementations. There are several already to do it their way. This lets X3D browsers and HTML browsers continue to evolve, and our spec won't go out of date because it describes the end result. Dick, what I just said might apply to many other things about X3D, that we're functionally oriented. What's your opinion about this approach?
Well, it's an approach that I think is quite common, but it is not a requirement. It is perfectly possible to implement X3D browsers outside of an HTML environment as separate applications. And we have several examples of that seem to be used more in an industrial sense than using HTML. That's one reason why we have other representations of the scene graph based on the requirements of whoever the authors are and whatever environment they're working in. But HTML is a very important one, and it's especially important for people who want quick representations of 3D models.
And we've learned some lessons over the years. I think that our insistence on a consistent user experience rather than one way to write your code has stood the test of time, and it shows that the spec remains relevant even as software and web development matures. We've got another major piece here, and that's web audio. Web audio is interesting because it's now standard. It was many years in percolation. It's widely implemented in web browsers, and it's an API. It's a JavaScript API, and it could be JavaScript sitting on top of other code, as the abstract says here, and it has lots and lots of things in it, but it's all JavaScript. Oh, X3D you can do X3D in JavaScript, but you can do it in many other ways too. So what we did, and thanks to the team in Greece, Effie Laka, Athanasios Malamos, implementing and defining this, we are able to do audio in an X3D way so that we can model it as part of a scene graph, take full advantage of that functionality and integrate it in 3-space as makes sense for the models that you're building. So pretty cool, pretty cool. I definitely commend that work to you. There's papers last year, this year, a tutorial on its way as well. Projective texture mapping is also a really serious capability. It's interesting. It's sort of halfway in between viewpoints and textures from a technical perspective, or excuse me, textures on geometry that we're all used to, and lights. You could think of it as a texture-based light that you could shine around in the scene and get that texture draping over whatever it happens to point to.
Think of taking a slide projector.
Korea has been a key contributor here. Dick, please.
Yeah, think of projective texture mapping as the equivalent of putting a slide in a slide projector and then aiming the slide projector at your model or parts of your model. And this allows you the it's a light source, and yet it's also a texture. Go back to the earliest one, Don.
Sure thing.
There. As you can see, we're shining a slide projector at the corner of this, say, a room, and it behaves differently on each of the surfaces, but the texture still applies, and that could be any texture. It could be a photograph, could be anything. And so what this texture does is allow you to spray images on arbitrary things.
And those images could be 2D textures or pixel-based numeric definitions or movies. And so powerful new technique. It'll be very interesting to see people start to extend and improve that. We've done a lot of little things here and there to make scanning, 3D scanning and point clouds better supported. And must thank the CAD Design, Printing, and Scanning Working Group for figuring out what were the little addition things that we need to really have a good workflow from beginning to end. We'll see some of those results at the end of this talk. We've also matched X3D support for the humanoid animation specification, which is been around a long time, got fixed and improved 2 years ago. That's an updated ISO standard, and what's great about this standard, this update, is it's not only very solid in all of its definitions of what a humanoid is and how do we define it, but we've added motion animation that's patterned after BVH format and quite capable. We've shown how to do it in more than one way in the standard, the HANM standard, and then we've shown how to align it directly with X3D in the X3D architecture.
Yeah,
Dick, that's been a long journey. What are the most prominent lessons learned in your opinion?
The HANM standard emphasizes the ability to accurately represent humans and human characters. It has been carefully designed so that any other articulated figure can be represented. For instance, it's easy to represent things like an octopus or an alien animal with 6 legs or whatever, and but it still does it in a standard way. And all of those different representations should be possible.
That's right, and we've doubled down on that by saying, well, let's do humans really well. And I got to give a shout out first to Joe Williams. A lot of diligent effort. We now believe we have a fully complete, anatomically correct human skeleton with corresponding skin bindings. And looking ahead, our colleagues in Korea have shown that these exact same design patterns can be used for internal organs and possibly facial expressions too. So it's interesting when we move out of proprietary code bases and different ways of doing things and say, oh, we could have an open standard that's not only general for humans or animated characters, but it's rigorous enough that it might someday go all the way to human medical records and be a way to record people's physiology, people's diagnostics, changes, and just your personal health. So we expect to see more good solid work building out on HANM. Okay, let's keep driving on here. So from an ISO workload, work path progress, we are, let's get my laser beam again. We are here on the, we just submitted a CD, which appears to be functionally complete. It's now gone to national bodies for review. And we're working through, Dick and I, with the backstop of the X3D working group. We're making sure all of the phrasing is unambiguous, that software builders can read the spec and go, oh, okay, I know what to do. That modelers can read the spec and go, I know what to expect. And so, gee, Dick, it sort of feels like we've come full circle to the purpose of Web3D Consortium. Let working groups and the public have a protected haven to do fast technical work, and then the longer timelines of ISO can proceed in parallel while everybody has great confidence that it's going to go forward. Is that ringing true for you? Am I just doing happy talk here, or what do you think?
I think it's we should put a shout out to Roy Walmsley, who for a few years did a very, very rigorous review of the prose in the standard, and also the various connectivity portions of the fields, and making the field use of fields and nodes consistent. He's no longer participating, but a lot of the editorial comments we're currently looking at are a direct result of his very careful review. Being he's from the UK, so he understands English very well.
Yeah, we miss you, buddy. Roy's direct experience with the Quite 3D library meant there were few secrets that he couldn't get to the heart of, and we're still benefiting from his insight. Okay, and it is what it is. We're gonna keep working on 4.0 and sort it out. Can people work on 4.1? Things like mixed augmented reality, VR, AR, XR, other things. Sure, go get them. Have a great day. But we're gonna make sure this 4.0 is rock solid across the board, across all these variations, and that's functionally stable now. So the ongoing good work, often driven by implementation and evaluation, can continue.
We should be able to finish the 4.0 development and have a published ISO standard in early 2022, because I'm still old-fashioned. But once that is done, the next thing is to get all of the encodings and language bindings caught up with the 4.0 abstract specification, and that will require a lot of auto generation. So the object model will be critical in quickly developing all of those different standards.
Here, here, and everybody will see that all this stuff is proceeding in parallel, and there's no blockers to these other things occurring now. I don't know if it's a bottleneck or just the gauntlet we always have to run is make sure that document can stand the test of time forever and ever, that everybody's comments and good ideas and, hey, wait a minute, all get reconciled. And Dick and I continue to spend a number of hours each week just to make sure that's going on. Okay, so now we're going to have a lot, that's the big picture. We're going to give you a lot of snapshots on figs. C++ C#, they're all pretty similar. They have the same DNA, but different. Here's the status report. There's been great work by Dr. Myung-Won Lee and her students and her colleagues, and we hope to capitalize on all our success with other things to regularize that. So that thing's in motion, and stay tuned or get involved, please. What do you say, Dick?
I agree. Should be noted that the scene access interface has two different methods for accessing the scene. One is through internal scripts that are part of the scene, and the other are access from external programs. In the case of C, C++, and C#, these are going to only provide external access. But since the application development is very commonly uses C and C++ and C#, this will allow them to more easily interact with the scene and make whatever changes the application being developed wants to do.
Very good. And at the end of the day, it's still X3D.
Yep.
So next, H&M. We've got a number of examples online. I think we have maybe 80 formal examples. They've all been tested and validated. So this past year has been a lot of tool confirmation, tool improvement to make sure this is all working. And there's a couple of pointers there to future work. We're seeing some other synergies with the semantic web work. We were working on aliases. Frankly, I don't know how the doctors talk to each other, because we have not been able to find a single reference for all medical nomenclature. But there's a lot of common practice, and there's variations all over, just in English, much less other languages. We think we have the major aliases captured, but we can get out of the alias business because semantic web techniques give you a much better way of drawing those correlations, including across programming languages. Okay, next is ISO document status. And so the Web3D Consortium, because we carefully protect the intellectual property rights going in here, we accept all comments in the public, but the working group Web3D members get to decide what goes in or not. And we do not accept something if there hasn't been confirmed by somebody who says there are no known patents affecting this. And this goes all the way back to 1998 when we first established Web3D Consortium. So the bashing is all public. The issue tracking is in Mantis with members. The actual documents are in GitHub, but they're private access to members only. And then when they reach a high state of maturity, they go public, as the X3D4 architecture is today. Okay, let's step forward. Mantis then is our issue tracker, and you've got just a scoop here, a snapshot. Dick and I keep pounding through editorial issues. We think we've got the hardest ones done that might affect ambiguous functionality, but we continue to plow through them, and I share Dick's at least optimism, if not optimism, at least hope that we finish this year. But we've been surprised before. Some of these things take a lot of careful thinking, phrasing, and comparison.
True.
Okay, so I should say that this is all there. Any member, whether you're a company member or a university or an individual, you can get full access to everything here and make your voice heard, make your feature properly, fully defined.
And non-members have the ability to add comments to the Mantis bug tracker. And if they are submitted as X3D bugs, we are very careful to review each and every one of them.
Amen. So that's the first half of the slide set. Here's the second half. Lots of resources on parade. So let's start. This is the first page to go to if you want to see what's the latest and greatest. It's web3d.org/X3D4. And there's a long history in here. We've done it for years and years, including when the X3D4 was, my gosh, 4 years ago at the Web3D conference. We've had annual updates, and what looked like maybe insurmountable then is all yielded and is coming to fruition now, including this slide set, which is the first entry on here. Okay, and then here's the specification itself. We linked to that before. I'll click on it right now just so you can see, yep, it's there. I can turn off my laser beam. Boom, presto. There it is. So you can navigate your way in and you can see what is the latest, greatest in the opinion of the Web3D Consortium, in the opinion of the X3D Working Group, informed by the public on the X3D public list. Lot of stuff, and Dick and I don't stay up late at night inventing things, rather quite the opposite. It's a cumulative effort since 1997 achieving a large and formidable body of capability. Okay, now let's march through some of the browsers, some of the players for X3D. There are several that are just utterly great and really keeping track of what's going on. We wanted to recognize Michalis Cambarellis and his immense efforts with glTF, getting it all to work. He also has a converter. He's also fully immersed in all of the details of both encodings and how they might work. You can barely shake a stick at all of the examples and results that he has online. So open source, it's supported by users. It happens to be in Object Pascal as his main language, but he's got full board glTF and hardcore libraries underneath. Many features first come to light through his code base and his tool sets. Next most popular, or very popular, I shouldn't say next most popular, but the next one, which is also very popular, is X3DOM. And this emerged out of the Fraunhofer experts, and there are tons of people working on that. It's all, again, open source. It's out there. It has great support, great uptake. Still got a few gaps. We still are encouraging people to build some things, but absolutely a workhorse for many folks. So if you want to put X3D in a web page, you can use X3DOM for that. And we have, well, 4,000 examples roughly online that show exactly that. And then we have Xsite, which is the other major JavaScript browser. And in fact, I believe that Xsite is still probably got the greatest support of any of the players. We haven't done an inventory too recently, but they're up in the 90-something% of full capabilities and no doubt working on some of the X3D4 things. So tremendous. Here's about 20% of all of the Excite examples that are just on the Excite set and website. And Holger Selig does amazing work and stellar rendering, as you can surmise from just some of these postage stamps. Closely related is he has an authoring tool that shares a lot of the same code with Excite and is used for on Linux. I'm afraid I wish it was more operating systems. Maybe someday. We just got a Linux system finally dedicated in the lab. Hope to start banging on this pretty soon. He's got some really magnificent tools as part of this authoring environment, and quite dramatically effective as a authoring tool. Free World, honorable mention, a lot of good things going on there too. Again, open source, this time C++. So it's an application browser, but these are, most of the words you see on here come from the source, come from the originator. What do they say? So please check it out. They were one of our first hardcore checkers that all of the glTF mapping could coexist well with the existing X3D render model. Okay, and then we have the mother of all laundry lists. It's just grown and grown over the years. When there's something interesting about X3D, we put it in here, and tools, resources to help authoring, books, conformance testing, conversion, examples, details on examples. These are all in version controlled examples, import, export, and the nature of open source. How do we go mobile? Searching for models. This is pretty interesting. I foresee that we'll probably be getting into the business of 3D search metadata in the coming years. Links to our different programming libraries that are out there. Quality assurance. How do we ensure that models are correct? Oh, and by the way, when they're correct in one form, then that tends to make them correct in the other form too. And as you might imagine, that's quite a big job, and it's all mutually beneficial. Every time we fix a bug someplace, we raise the bar elsewhere. We can digitally sign and encrypt X3D models in the XML form using other existing standards. So that kind of encryption is available today. And we've learned that if you want to compress too, well, it's a good idea to compress before you encrypt, or you won't be able to compress. All those details are here, including known security vulnerabilities. Curiously, if you read the fine print here, you see it's a really short list of just the X3D design prevents security vulnerabilities. But when we see somebody supporting ways to check, when we see flaws or hazards, we document them and share them, etc., etc., etc. Okay, so those are the resources. If your resource is missing there, tell us. Post it on the public list. We'll add it. Scene authoring hit. This is where we've collected one by one over the years all the different ways to take care of X3D. And because it's a big standard, because it has lots of interesting design patterns, because it's the web, because it ties to various multimedia, there are a lot of lessons learned and gotchas and good practice that you can take advantage of. So if you're asking, how do I do this? And you're getting beyond the tutorial stage, scene authoring hints can help you. Okay, and oops, been there, done that. Tooltips. Tooltips, boy, well, we have a spec. You don't need tooltips. If you want to read the functionality, just go there. But we have found over the years that there are lessons learned. And it's helpful to have this kind of short form. So for every node and for every attribute, for every field in the spec, we have tooltips and hints. A lot of it is redundant because we have consistent internal design in X3D. So, you know, if you learn about def and use, identification of nodes and reuse, well, you know how it works for all the nodes. But if it's an X3D4 new capability, then you see it in yellow here. And it's so identified. If it's something that was always there, well, okay, it's just in green. If we have authoring gotchas, hints or warnings, we toss those in. Okay, so painstakingly constructed. I want to get back to the index. I click on the little X3D. And if I want to see what it is, well, the very first link here always takes you right back to the spec and the index and then the spec itself. So the specification is authoritative. If there's ever daylight or gaps between the two, then we fix the tooltips. Interestingly, these tooltips, since they're structured data, we can use them in a lot of these APIs. So once again, cumulative mutual benefit. Okay, conversions, these are sections in the resources. There's lots. By lots, I think, I don't know, we're up to 3 dozen in this one and another 15 or 20 in the other. And those are just the ones we've been keeping track of. Many ways to convert because X3D is an interchange format. Our goal is archival use, reuse. Blender will be one of our biggest challenges in the current year. Not challenge so much, technically not a challenge, it's just opportunity with X3D4. How do we mainstream that in the stellar capabilities of Blender and the new features of X3D? It should all work. Plenty of times for people to get involved. X3D Validator, this is one of the NPS things. Let's take hello world and validate that and see what happens. You can select a file on your local system, or you can put in a URL and somewhere a server is crunching, and more than a few links here of how it all works. And what it's doing is it's going through about 9 different tools that have different ways of testing an X3D model. And so here's our result. Let's see what it says about our hello world model. Okay, it says it's 3.3. It's passing XML checks, docs type, headers, DTD validation, which is string-based, schema validation, which is data type-based. We have some additional checks when we convert back to VRML 97. You can, so basically, this is a backwards compatibility check. We have regexes, regular expressions that look for malformed floats. Those can be insidious errors in your model if you're unable to detect them. Schematron is a bunch of rule-based testing. Well, if I have this there, I shouldn't have that there, or make sure you add the other thing. Tidy is a cleanup. And then finally, the pretty print. How do we turn that plain old XML into linked and hinted HTML so you can get a basically documentation for your model. Okay, so that's the validator. Very useful tool. Quality assurance means you avoid garbage in, garbage out.
If you have some trouble with something not working right, running it through the validator might point out exactly what's wrong.
That's right.
It will speed up your development.
And then sometimes the errors identified in the first part are answered or hinted in the second part in X3D Tidy. And Schematron, they say, well, I want to do this instead of what you did. And if you're still stymied or stuck, please tell us, because every one of those rules was built one at a time. And if you found a hole or found a gotcha that's new, great. We want to give it to everybody else and we'll integrate it. Okay, I'm happy to report that X3D Edit is climbing back on its feet after some downtime. We've got it, I built and ran it just this morning. We hope to update our auto installers in time for the conference. Active work. Here's an example of a material editor in there and what it looks like. We have XJ3D integrated in here to visualize things, yet another browser. XJ3D doesn't yet have a whole lot of support for X3D4, but it is open source. It's Java. It's pretty powerful, and we're certainly keen to keep that thing going. Okay, shameless plug corner is a book. We do have a book out there, X3D for web authors. Tons of slides, tons of video, tons of models. We have used this for a course here at NPS. That course is now online. So if you want to teach yourself X3D, and this matches the level of detail in the VRML source book, another great reference, you can use that. Okay, I mentioned examples. Well, here they are. You can count up. Okay, we just broke out. Yep, sure enough, 79 H&M examples online. 416 examples from that VRML source book. That's in fact where we started with X3D, is converting all the source book examples into X3D. We pursued that further with the NIST conformance suite, which had an immense set of tests for VRML. They're all upgraded and up there. Okay, so we're creeping up to 4,000 models here. Pretty interesting. And we keep logs of unit testing of all of our quality assurance for that. Okay, next reference is for validation. Where do you get those documents? If you're a tool builder, you want to use them. Well, it's all online. They're referenced in each scene, but here's where you get them. As with most of our work, it's version control. So when there's an improvement or a correction, there's definitely a trail and a history of how this all works. Here are the links to the unified object model. Again, this is a machine readable version of what the architecture says, and it's used to auto-generate the next things, such as Java. We have a full-up Java library. The Java slang for this is it's all plain old Java objects, POJO. So you can just use it with any other Java program. Similarly, Python, there's no dependencies on other libraries that might conflict with what people do. It's all, as far as we can make it go, best practice Python. And automatically generated and automatically installable in your local Python through PyPy, the Python interface library.
It's important to note that Python.
Okay, we've done.
Python is a language that was developed after X3D, and yet when we started developing a Python interface to X3D, it turned out to be relatively straightforward using any of the Python environments.
Correct. Thank you, Dick. Okay, we've done a lot of work on JSON. It's not formalized yet. We've been waiting on the JSON schema to get locked in over at Internet Engineering Task Force, but that's now appears to be at a pretty high level of maturity. John Carlson is Coder Extreme is our main man there, and he's got an updated JSON schema that he is auto-generating using the Python package x3d.py. And so now we're going all the way around the world and back again because of this consistency. And we're soon to get into testing of the update to the JSON schema. Pretty interesting stuff. There's the links to John's work. His biggest contributions are the JavaScript library for X3D, all hand-coded. None of his stuff is auto-generated. It does leverage some auto-generated stuff, but he's got his work in open source version control, and you're welcome to check that out. Okay, other work documented in online is how do we get X3D into the semantic web so we can start doing queries and other things. Jakub Flatinsky and I are working together on that one, and it's yielding. It's by looking at patterns, design patterns, and best practices. We have auto-generated ontology. It was reported out in great detail. You should be seeing a tutorial from us in this year's conference. And there's no doubt a few things I'm missing, but even with all that immense detail. But a shout out to the conference itself. ACM, SIGGRAPH is the primary sponsor. The conference site is now on web3d.siggraph.org. Got to point out the webpage now has not only 10,000 downloads of papers this month, 25 years of papers, but we're getting close to 250,000 downloads altogether. And that's since they started. I'm not even sure when their starting point was. Our publication point was 95. Wow. 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 This is all adding up. Here's a point of interest that happened in a meeting this week, so I tossed a slide in. Yes, indeed, X3D is a registered trademark, and at least in the United States, and you can look at that. So the Web3D Consortium is looking out for everybody's interest to make sure that X3D not only stays well-defined, functionally correct and complete, but stable. Okay, Dick, I think we're on the end game now. Some eye candy. Shall I put the video up?
Sure, go ahead.
Okay. Here was work by Versar, John Ouellette and his team, and also Virginia Tech, Nicholas Paulus and Peter Sforza. And they've been modeling the Naval Academy, U.S. Naval Academy in Annapolis, Maryland. And I have a confession to make, Dick. Every time I start seeing some of this stuff, I have this sudden urge to shine my shoes and show up in formation somewhere. So, you know.
Just stand up and salute. That'll do.
Yeah. If I suddenly start marching, please take over. You know. But anyway, you can see this is immense scene, a lot of stuff. I think Nicholas described it the other day. They have at least 7 different sources of data that they've integrated. The trees are not exact tree scans of one day, but rather tree models that are put in the right places and size. A lot of different databases got pulled and modified to show these things. This is not a pretend location. This is a real location, and you're seeing firsthand some of the, not just the features, but the ability to take advantage of the web. These floating boxes over here, these are not drawn with X3D. These are drawn in HTML. In fact, you can look at the URL in this video we're watching right now. You see, oh, it's an HTML page that contains all these models and models holding other models and building a big place. And wow, that's pretty cool. This one was done, yeah, April 1st. No, really. And Nicholas was showing me an upgrade the other day. We were talking about it's getting so big, it can get bigger than even new machines. How do we take care of that? You just saw a second ago, well, here's the underwater portion of the scene. This was done by side scan sonar from an underwater vehicle and merged with a bathymetry database. And a lot of the land, the shoreline, and other things were done by air vehicles. The Army Corps of Engineers collected some significant data sets. He also walked around with handheld scanners and not yet in this model, but being integrated are tunnels, scans of tunnels. So here we go. Nicholas's compression discussion ended with, well, since X3D is web-based and its URL is an ordered list, you can put any version, the lower fidelity, the compressed, the higher fidelity, the super high fidelity on a list. And depending on what the author wants, and depending on what the user has access to, then the right resource gets chosen at runtime. Okay, and it's still going. Let's hide that bad boy, and you can see here on the right, that's Dr. Paulus. We grabbed a few of his screenshots. He's showing the same content in a cave, and he's walking around and striding over the campus and inspecting and clicking and exploring things and improving the model yet further. Oh, same X3D. So you can run on a desktop, you can run in a web browser, you can run in a cave, you could run in headset, same X3D. And just when you think we've said, go ahead, Dick.
Yeah. You can also run on your smartphone.
Thank you. Yeah, and I should probably call it up. If we go to the globe model, you're going to see that in Web3D user experience tutorial. Yeah, you can query the globe for get your weather report on your smartphone as well, using X3D in that case. You could probably do it in Excite too. We'll prove that out. Okay, and if you just when you think we've overflowed and said everything, we realized right before the talk today that, oh, we forgot to mention 3D printing. So here's a link to a project. Again, happens to be NPS, but we took a vertical projector overhead and 3D printed some of the same models that exist in this 3D scene and started superimposing them and pushing toy boats around the table and looking at it. So if you want a detailed slide set of how we put that together, feel free to go there. 3D models can be rendered in all those different ways, but they can also be rendered physically, printed out, and
it should be noted that a lot of the commercial 3D printing companies that provide a 3D printing service use X3D as the basis for their models.
Exactly right, including Cura 3D, open source software by Ultimaker, which is the #1 3D printing software, native support for X3D. can load it just fine. I think our unofficial slogan is, but wait, there's more. But not today. We appreciate your time. If you made it this far into the tutorial, we want to acknowledge that this is absolutely a team sport. We've just listed here the folks who've directly helped in recent years on the specification. There's a longer list back in some of the documentation. We're grateful. Everybody has benefited from everybody else. And as you've seen from just a few snippets here today of actual models, but the grand variety of things emerging in the conference. Wow, 3D is moving out to the web. X3D4 is stable. It's available. People are putting effort into tools and models that illustrate it. Dick, what's your lead out statement? What's your get off the stage statement here about what does it all mean?
Well, one of the nice things about X3D is that if you have developed a model in X3D 3.0 and you want to take advantage of some newer feature, all you have to do is change the header statement and then add the requisite scene graph elements for the new feature, and everything works.
So backwards and forwards compatibility is part of the mix here. And how do we keep striding into the future without losing anything that's come behind?
Everybody should really enjoy their 3D.
Yep. Our contact information is on the last couple of slides. Again, we're grateful for your time. We're grateful for everybody who's working on this. We're grateful because it's fun to be part of and powerful. And gosh, what a shared public resource for everybody.
Thank you for attending.
So sorry, Dick, go ahead.
I was just going to thank everybody for attending, and if you have any questions, our email addresses are on the contact page.
Outstanding. Okay. Thank you.
Bye-bye.
Bye.